This video will be reviewing how to evaluate a function and also elaborating on that concept a little bit. So first, we have two functions that we're going to be looking at for the examples in this video. Over here in green, we have f of x equals x squared plus 4x plus 2. And then in pink, we have g of x as another function that just equals x plus 3. So just to review some evaluating here. If we look at example 1, it says f of 3. So basically what they're telling us here is we're going to take the function f and we're going to replace all of the inputs, all of the x's, with the value 3 and then just simplify. So if we rewrite, we'll have 3 squared plus 4 times 3 plus 2. And then if we reduce this, so 3 squared is 9 plus 4 times 3 is 12 plus 2. And then we can just kind of add everything all up. So 9 plus 12 plus 2, 23. So that means that f of 3, so the output to the function f when we input the value 3, gets us 23. So you can go ahead and try the remaining ones on here if you want and pause the video or follow along with me. We'll take a look at example 2 here, plugging in -3. So what does that change exactly? So in this case, I'm going to definitely use parentheses. I probably should have on the first one, but wasn't really necessary based on the values. They wouldn't have changed anything. But in this case, we have to remember that when we square -3, that gets us +9. But when we multiply 4 times -3, that does change it to -12. And then still adding 2 on the end. So 9 plus -12 plus 2, we're looking at -1. Now, example 3, we're changing to inputting a variable. So in this case, basically, we're just going to switch all of the x's to b's. And then if we can reduce, we should, but because we couldn't reduce with the x's in there, that's about as far as that one can go. We can't combine like terms or anything like that. So that is the simplified version. The last one, however, is going to actually get us ready for something we're going to do later on this page called the difference quotient. But in this case, instead of just plugging in a number or a single variable, we're going to plug in a binomial. So let's see what that looks like first when we sub it in. So we're looking at x plus 2, the quantity squared, plus 4 times the input x plus 2, plus 2. Now, if we look at the first thing, we have x plus 2, the quantity squared. So what does that mean? Well, remember that when you have a quantity squared, that's technically the number or the quantity times by itself. So we do need to FOIL or box that. The second term, we have 4 times the quantity x plus 2, so we'll need to distribute. And then obviously the plus 2 at the end will just keep in place. So I'm going to come over here. We'll have x squared, so FOIL or box, plus 4x plus 4. Then distributing, we get 4x plus 8 plus 2. And at this point, we can combine like terms. So we get x squared plus 8x. And adding up all those constants, we have 14. Beyond just basic evaluation of functions, we can do something that's going to kind of preview section B here, which is called composition of functions, which you'll be learning about in Khan Academy. But we can do the basic 4 operations, add, subtract, multiply, divide with more than one function. So you can see here I have 4 examples showing you one of each type. And looking at the notation, it looks a little weird. So what I did for you is I laid out how it would be written first. So for example, we might see this as our question being asked. And again, we're using the same 2 green and pink functions from earlier. And what that's basically saying is add the 2 functions together. So if we rewrite this, f of x plus g of x, I'm going to take the function f of x, which is just x squared, plus 4x plus 2, and add to it the function g of x, which is x plus 3. And then from here, adding and subtracting are just combining like terms. So final answer should be x squared plus 5x plus 5. Okay? So maybe you want to pause the video and try the next one because we're just changing it to subtraction. If not, here we go. So in the second one, we're subtracting. We have to be careful here because of the subtraction. We're going to need to use distributive property with the negative because obviously everything in that function g of x is needing to be subtracted from the original function. So f of x is still x squared plus 4x plus 2. But now we're doing minus, and I'm going to put g of x in parentheses, so x plus 3. And then before I do anything further, I'm going to go right away and add the opposite. So make that a negative x and a negative 3. So final answer for this one, still x squared. But now we're going to have plus 3x. And in this case, minus 1. Now for number 3 and number 4, you can see they've switched over to multiplication. So in this case, when we're multiplying, this isn't the greatest example because we don't really like to have to multiply such large polynomials, but f of x is a trinomial, g of x is a binomial, so you'd have to make a 2 by 3 box or distribute twice, however you want to do it. But go ahead and try that on your notes and then and pause the video and come back and I will have the answer up here just as the final. All right, and if you've tuned back in, your final answer should be x cubed plus 7x squared plus 14x plus 6. And lastly on this one, we'll show you division. So in this case, f of x is the top function. They could be switching the direction all of these. So if you can add it, f of x plus g of x, you can subtract f of x minus g of x. You can do that in reverse. We just, again, have to be careful with our signs when we're dividing really and subtracting. Multiplication and addition are commutative. We can flip-flop the order if we want. But for division, they want the f of x function on top. So we'll make that x squared plus 4x plus 2. And then we're dividing by g of x, which is just x plus 3. And then in this case, if we were able to, like I could check right now, since this is a rational expression, I could check that the top was factorable. That would have a term to cancel out. But in this case, I can't actually even factor the top. There's not two numbers that multiply to 2 and add to 4. So I'd have to use quadratic formula to solve that, which means there's nothing I can do to simplify that any further. So this is actually the final answer for this one. No work needed. Now, the last thing that we're going to talk about here in this set of notes is the difference quotient. So the difference quotient is something that you'll talk a lot more about in either of the calculus classes. But the difference quotient looks like this. It is f of x plus h minus f of x all over h. And for the context of this problem, we will work with the function f of x equals x squared minus 4x plus 7. So our difference quotient is really just an evaluation of two function notations. So in the first part of the numerator, we're plugging in x plus h for all of the x values in our function f. And then we're going to subtract from that f of x. So if I rewrite the function f with x plus h, that is going to look like this. So it was x squared. We're now going to do x plus h squared. It was minus 4x, so now we're going to do minus 4 times the quantity x plus h. And it was 7, so we're still going to add 7. Then we're going to change over to minus, and then very importantly, we're going to use parentheses because, again, we just talked about subtraction. Got to make sure we're subtracting all of the following terms. And then all of this is still over just a regular h. All right. So from here, we need to obviously simplify this down. And what you're going to find is as we start simplifying, this is going to actually come out quite nicely when we're all said and done. It won't be like just a regular number or just like x or something like that, but it'll simplify to a pretty easy to look at expression. So watch for patterns as you're doing examples of this. So our first thing we want to take care of is this x plus h, the quantity squared. So box or foil, because we are squaring this quantity, but jump back into the video here in a moment and double check your work there. And then next we would distribute the negative 4 in. So that would be minus 4x minus 4h. Don't drop this plus 7. That happens sometimes because it kind of gets mixed in with a lot of other stuff. So we want to be careful that we're sending that through. And then the last piece is to rewrite this function, but now we're going to subtract. So we'll have minus x squared plus 4x minus 7. Still all over h. And if you take a look, we should start to see that there's some common factors that we can add together, common terms. So we want to combine all of those. So if I look, I start to see, let's get a different color here. I see there's an x squared term and a negative x squared term. A little too much. There we go. So those are going to cancel out. So I don't have to worry about those. Let's grab a different color. Let's do this burgundy. What else do we see that are like terms? So we have a negative 4x and a positive 4x. Also going to cancel out. So far we have nothing. If we keep looking, we have a 7 and a negative 7. Still no like terms for us to be writing in the next line. If you look at what I haven't highlighted, we have 2xh plus h squared minus 4h. And all of those terms have an h in it, so I could factor that out, and I'm simply left with 2x plus h minus 4. And that's it.